Welcome back. This is the final video for this unit. We are going to talk about isosceles and equilateral triangles. First, let's talk about some vocab that has to do with isosceles triangles. First, we have the legs. These are the two congruent sides of an isosceles triangle. Next, the vertex angle. This is the angle that's formed by the two legs. The base is the side that's opposite the vertex angle. And the base angles are the two angles formed by the base and the congruent sides. So for example, in this picture, I have the legs are the congruent sides. The base angles would be 2 and 3. And angle 1, the angle across from the base, this is known as the vertex angle. Now I want to teach you what's called isosceles triangle theorem. It can be abbreviated ITT. Here's what it says. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So for example, if you know that segment AC is congruent to segment BC as shown in the picture, you can conclude that the angles opposite those sides are congruent. So the angle opposite side AC is angle 2. The angle opposite side BC is angle 1. Therefore, angle 1 and angle 2 must be congruent by ITT. The converse of this theorem is also true. It's called the converse of isosceles triangle theorem. Remember, for converse, we must switch the hypothesis with the conclusion. So this states that if the two angles of a triangle are congruent, then the sides opposite those angles must also be congruent. For example, the side across from angle 1 would be segment FE, and the side across from angle 2 would be segment DE. Therefore, FE and DE must be congruent, and triangle EDF is an isosceles triangle. Let's try this in a practice problem. It says name two unmarked congruent angles. So if they're not marked already, we cannot use angle D and angle ACD. Those are already marked. However, I see that I have these two sides marked as congruent, so I'm going to highlight a triangle that I see that has those two sides as part of the triangle. So I'm focusing on triangle ABC here. And I know that the angles opposite those sides must also be congruent. So I'm going to mark those in my diagram, and then I'm going to name them. So I know that this can just be called angle B since it's the only angle at the vertex B. However, this angle over here, I need to call it angle ACB or angle BCA, because there are multiple angles with the vertex of C. Next it says name two unmarked congruent segments. So this time I actually want to focus on triangle ADC because this is the triangle that has two angles marked congruent already. I know that angle D is across from side AC, and angle ACD is across from side AD. I know that since the two angles are congruent, the sides across from them must also be congruent. That would be by the converse of isosceles triangle theorem. So notice that when you are just concluding something based off of ITT, you're saying that the angles are congruent, whereas if you're using the converse of ITT, you're saying a pair of segments is congruent. Pause the video and try the practice problem below. Here are the correct answers. Now let's talk about equilateral triangles. This is this biconditional statement is true. A triangle is equilateral if and only if it is equiangular. I know some of my students have already pointed this out and realized this. If you haven't, now you know. So basically, since it has the statement if and only if, it means it goes both ways. So if a triangle is equilateral, then it is equiangular. And also, if it is equiangular, then it is equilateral. Another fact that you need to know is that each angle of an equilateral triangle must be equal to 60 degrees. Think about it. The sum of all the angles, angle F, angle D, and angle E, must add up to 180 degrees. The only way that's possible is if each angle measures 60 degrees. Let's use this in a practice problem. First it says find each measure. We're looking for the measure of angle Y. Now the first thing I notice is that segment XY and segment XZ are congruent, and I can't just find angle Y based on the triangle angle sum theorem because I only have one angle given to me. However, I know that the angles across from these two sides must be congruent because the sides are congruent. So I know angle Z and angle Y must be congruent. Now, knowing that these two must be congruent, I can call them X and X. So now I can write this equation. 60 plus X must be equal to 180. That's called triangle angle sum theorem. Now to solve this, I would combine my like terms, subtract 60 on both sides, and finally divide by 2. So I know that the measure of angle Y must be equal to 60. Now that I know that all three angles have a measure of 60 degrees, I know that this is an equiangular triangle. Therefore, it's also equilateral. So if I need to find the measure of side YZ, I know that YZ must be the same as XY or XZ. Therefore, YZ must be equal to 8 inches. I would write a note to myself so I don't get confused if I'm looking back at my notes. Where did that 8 inches come from? Well, I know equiangular triangles are always equilateral. Let's do one more practice problem together. It says find the value of each variable. So first of all, I see that angle A and angle B are congruent. Therefore, the sides across from those angles must also be congruent. AC is already marked with 1 dash, so I'll go ahead and mark BC with 1 dash as well. Now that's helpful because I see that triangle ABC is equilateral. Any equilateral triangle is always equiangular. Therefore, I know that angle C would also be congruent to angle A and angle B. I also know that in an equiangular triangle, all angles measure 60 degrees. Therefore, I know that 2x must be equal to 60 degrees. So x must be 30. Next, I see that in order to find y, I know that these two sides are congruent, so I can set their measures equal. Add 5 on both sides and divide by 4. Alright, finally, before we end the lesson, I'd like you to reflect on this question. In isosceles triangle ABC, the measure of angle B equals 90. Draw the triangle. Indicate the congruent sides and label each angle with its measure.